Hi everyone, welcome back to my channel. I am Dr. Shahbaz here. So in this video, we will learn how to perform and interpret MANOVA or multivariate analysis of variance in R. MANOVA is used to examine whether two or more independent groups differ significantly across multiple related continuous dependent variables simultaneously. For example, we may compare different teaching methods based on students' mathematics, science, and language scores. So in this way, the null hypothesis states that the groups don't differ across the combined dependent variables. A multivariate p-value below 0.05 indicates a statistically significant overall group difference. The main assumptions we will learn, and we will consult our PowerPoint presentation to see the assumptions before conducting MANOVA in R and criteria and the threshold values. So in this way, I will demonstrate how to check the assumptions, perform MANOVA, interpret the multivariate results, conduct follow-up analysis, and save the findings in the end. So please like the video, subscribe to my channel, and turn on notifications for upcoming videos on R data analysis. So now, first of all, we will import our dataset in R. So I just give dataset to ChatGPT and I told it that we need MANOVA analysis coding and we have a set of 15 observations with categorical variable method A, B and C, and there is test score and confidence level. So first of all, we will import the data in R. So ChatGPT give us prompt, we will copy this and then paste in console and then press enter. So you will see a dialog box opened in front of us and we need to select the data file MANOVA student performance and then click open. So data has been opened in R successfully. So in this way, before conducting, we will see our PowerPoint presentation to learn the criteria, assumptions, and MANOVA in R. So we are conducting multivariate MANOVA in R. So we are testing group differences across multiple dependent variables simultaneously. So a practical lesson on multivariate hypothesis, assumptions, Pillai trace, test, follow-up test, and interpretation. So in this way, MANOVA analyzes several outcomes together. Does teaching method affect students' overall academic performance profile? So this is our research question. So it means grouping factor is our teaching method with teaching method A, B, and C. And we are testing on one side test score and on the other side confidence score. So both are our outcome variables, mean dependent variables. So MANOVA tests the outcomes as a combined multivariate response. So in this way, our research questions and hypotheses are here. So first research question, do teaching methods differ on the combined outcome profile? Second, which dependent variables contribute to the difference? However, in case of multivariate hypothesis, H naught, the group mean vectors are equal, and alternative hypothesis states that at least one group mean vector differs if we are following the 5% significance level as 0.05. So this is our data, 15 observations, and these are the MANOVA assumptions to require multivariate checks. So independent observations, continuous dependent variables, multivariate normality with groups, linear relationships among dependent variables, no sphere multicollinearity or singularity, similar covariance metrics across groups. So there is also diagnostics and threshold test, Pillai trace, p-value should be less than 0.05. and the mean value should be greater than 0.05 to check the variance equality. And box M test, the value of P should be greater than 0.001 covariance equality. So in this way, now we will apply the coding in R and find the results for MANOVA test. So now we come back to our ChatGPT and copy the second prompt to convert method into factor, because we have method as categorical variable. So in MANOVA we need to convert this variable to a factor. So we will copy this prompt and then paste in R and then press enter. So it has been successfully created as factor. So now we will find the descriptive statistics of our dataset. Copy this prompt and then paste here and then press enter. So you can see test score mean, test score standard deviation, confidence mean and confidence standard deviation in case of method A, B and C. So you can see here in case of method A, confidence mean is 70.2 and test score mean is 71.8. And method B, the confidence mean is 61.6, which is decreased from the previous method A. Also the test score is 63, which is decreased from method A, which is 71.8. So there is also significant difference between two, A and B. So we will also check B with C and then A with C. So in case of method C, the confidence mean is 80.6, which is increased from the previous B method. As well, the test score increased from the previous B method. So it means in C, test score is higher than the B. So there is also a significant difference between B and C. So if you see from A to C, so there is also a significant difference between A and C. So now we check the comparison by post hoc test next. So we will go back to our ChatGPT and see the next prompt. So we need to find the correlation. We copy this prompt and paste it and press enter. So you can see the t value 60.047 and the degree of freedom 13 and p value is less than 0.05. So it will alternative hypothesis, true correlation is not equal to 0, 95% confidence interval. And you can see the lower bound is value is 0.9944 and upper is 0.9994. That means 0 doesn't come before lower and upper boundary of confidence interval. So there is a significant value. Sample cost estimates, you can see 0.998221. So there is a significant correlation coefficient between the variables. Okay, now we perform the MANOVA. We will copy this command and paste in R. So in this case, we can see the MANOVA model because R has successfully run it, and we can see here. This is a MANOVA. You can see list of length, 13, coefficients, residuals, effects, rank, integer, assign, and other values. So we have successfully run, and now we put the next to see the multivariate ANOVA results. According to Pillai trace method, we will copy and put it, then press enter. Okay, so according to Pillai trace, you can see method a degree of freedom 2 and Pillai value is 0.99173, and you can see we just consult this value. The p value should be less than 0.05. So in our results, the value of Pillai is greater than 0.05. The value is Pillai 0.9917 and the p value is less than 0.05. So it means there is a significant change. There is a significant difference of mean vector. So next we check the by using Wilks lambda that presenter. Okay, so there is also a Wilk value 0.080767 and the p value is again less than 0.05. So there is also a significant change in case of Wilk lambda test. So there is a significant differ of one mean vector from the others. Okay, now we use follow-up univariate ANOVA. Copy this command and paste here. So you can see the response test score, sum of square, mean square, f value is 55.531 and this is the p value which is less than 0.05. So there is a significant p value. And in this case, we reject the null hypothesis and accept the alternative because there is a significant change of one mean vector from others. And response confidence, you can check your method, sum of square, mean square, f value is 60.888 and the p value is significant because the p value is less than 0.05. Okay. So now we check the multiple comparisons in multivariate analysis of variance by using Tukey post-hoc test for test score. Then we will do for confidence. Okay, we'll put paste and then press enter. Okay, you can see there is a difference method B to A. So there is a difference minus 8.8. So as we concluded the mean square in the previous study, you can see here. So it has automatically calculated the mean, you can see. So it shows the multiple comparison from B to A, C to A and C to B. So there is, in case of B to A, there is a difference of minus 8.8. Lower boundary is minus 13.56 and upper boundary is minus 4.03. So it means 0 doesn't come between lower and upper boundary of confidence interval, as well the p adjusted value, basically this is Bonferroni adjusted value. So in this way the value of p adjusted value should be less than 0.05. So our value is less than 0.05. So there is a significant change, there is a significant difference of test score because we are testing the score. In the next level we will test the confidence. So we are testing the score. So in this way the test score is significantly different between B method to A. Okay, next you can also see method C to A. So there is a positive increase from C to A, as you can see here. From C to test score, C to A. So there is a positive increase. When we test A to B, so there is a negative decrease. It means decrease, there is a negative change. So however, in this way there is a positive increase from A to C. So in this case the lower boundary is 5.24214. So 0 also doesn't come between lower and upper boundary confidence interval, and the Bonferroni adjusted p-value, which is 0.000, which is less than 0.05. So there is also a significant change of test score between method C and A. As well, we test the C to B. So there is a positive increase from C to B, and 0 doesn't come between lower and upper boundary. As well, the Bonferroni p adjusted value is less than 0.05. So in this case there is also a significant difference from method C to B. Okay, so now we check the same pattern for confidence. We paste and then press enter. Okay. So you can also see here from method B to A, there is a negative change. So there is a high confidence in B method, however decreased in A. So you can see, so it means there was a confidence which was decreased from A to B, and the difference is negative 8.6, and there is lower and upper boundary of confidence intervals, so 0 doesn't come between two values, so this is significant change. As well, you can see the Bonferroni adjusted p-value is 0.0085, so which is less than 0.05. So there is also a significant confidence difference between method B to A. As well, you can see method C to A, the positive difference 10.4, 0 doesn't come between both values, and the Bonferroni adjusted value is less than 0.05. So there is also a significant change of confidence between C to A method. As well, there is also a significant change from C to B method. So in this way, we tested the method over test score and now confidence. Now we will check the equality of variances. We'll copy and then paste it. So in case of Flinger-Klein test of homogeneity of variances, the test score by method Flinger-Klein chi-squared value is 0.70775, and with the degree of freedom 2 and p-value is greater than 0.702, which is greater than 0.05. So it means there is no violation of homogeneity of test. And there is also, in case of confidence variance, the value of p is greater than 0.05. So in this case also we didn't violate the rule. Okay, next we will check the normality within groups. So you can see, according to Sperry-Wilk normality test, the Wilk value is 0.96222 and p value is greater than 0.05. So it means our data is normal for method A. As well, method B, the data is also normal because the p value is greater than 0.05. And method C, the Sperry-Wilk normality test, the p value is also higher than 0.05. So it means in all cases, in all methods, the data is on normal distribution. So we will also check for other. Copy this command and paste here. You can also see in all cases the p value is higher than 0.05, so it means the data is also normal in other case. Okay, now we have done the MANOVA analysis in R. So now we will save the whole results in Excel format. So we'll copy and paste here and then press enter. So R successfully created the Excel file with MANOVA student performance results. So you can find the results file in the same directory you have data. So you can see here MANOVA results complete. So you can see the results here. So in this way you can perform MANOVA analysis in R. So if you find my video helpful, please subscribe to my channel and press the bell icon so you can get my next video easily.